Okay, we definitely have a quorum. Welcome to Sarah Drake's Lounge, May edition, 2024. We're still working for the East Coast um, conference. Jay Wilson and has assembled a team, and they're working on that. He's still in need of papers or presentations. So I think he has four, and he would need about 10 at a minimum. So if you've got an idea of one, get a hold of Jay or myself and get on the docket. Uh, we also have my daughter's actually put together a store for the conference. So it's on demand, and you can get a mugs and shirts and everything with a beautiful new conference logo that she designed. And they're working on that as we speak. So that'll be rolled out here by the end of the month. And then you guys can order your own Eastern Conference, uh, stuff. Merch, I think. Merch is the official, term for that. Okay.
Merch
Um,
is it.
merch. Yeah. Uh, let's see what else. Also, I am call for papers for the May June uh, journal. So anybody wants to do that, if you have it in the May June journal, it does not preclude you from having it also in the conference, Eastern Conference. So you can also give that presentation there. So don't not give one because you want to do the other. You can do both. Um, okay. Let's see what else we got going. Uh, that's all I've got for now. Let's start. Ted, what do you got going on?
So I'm the Ezra guy, and I keep poking away at the software, but I really haven't posted anything new. I'm thinking about how to support more sorts of SDRs. It'd be great to do AirSpy. The way to do that is with SOAPy drivers, and I posted a little bit on the listserv how I'm slowly working on that process. It'd be great to zoom in on a certain part of the sky and display just that part of the sky in a plot. That would help on raster scans, for example, of a particular part of the sky. And if we were tracking something across the sky, what's the best way to record that data into my data files? Even if to record that location information. So things like that and lots of others. I just keep trying to poke in, but I never quite finish any of them. That's it.
Anybody have any questions for Ted on Ezra? All right. Okay. Let's get some of the overseas guys. Wolfgang.
Yeah, I can tell a little bit of some work I've been doing jointly with Vanessa. I think she's also on the call today. So what I'm going to tell you is a joint work that we did. You may recall that we made some effort to build a three-element, very simple interferometer, and I would like to share a few things about that. Hold on a second. Okay, can you see that?
Yes.
Oh, that's cute.
Okay. I now put it on full screen, so I hope everything is visible now. I think I've shown that picture before, just as a reminder. We have three cantenas, coffee can antenna or stovepipe, what we are using. The total baseline is about 10 meter. That's the maximum. And that is the arrangement at the moment. So we have some 2.30 meters, I believe, over here, and then the remaining to the 10 meters, the rest 7 meters something. And I've shown either on this serve or in this discussion a few things from our first slide, the fringes. Now, as it happened, because we're using the sun basically as the source, because we don't have much sensitivity, so we need a strong source. And it just happened that we recorded a big flare that everybody was talking about. So this is the data from the flare. It started around 7:30 UTC on May 8th.
No,
And
we're
then,
still looking at the building.
So what was the trick with that?
Seem to always be picking the right shared window.
Yeah, let me try that again.
You can also share a screen.
Yeah, let me just share the full screen rather than a part of it, and then we take it from there. So this is the building again, I hope. And this should be the next one. Can you see now the flare?
Looks good. Thank you.
Okay.
Yes.
So as you can see, it started around 7:30 and then went on through the morning, and then we had a very big flare around noontime. Now, the interesting part is looking at the scale. What we try to do is to roughly calibrate that using let's say, the standard intensity that we get from the sun, which at the moment is typically around 100 SFU. Just as a reminder, an SFU is solar flux unit, and that's 10,000 Jansky. So typically we have 100 SFU. And now you can see that with the biggest flare was 20,000 SFU. So if you multiply that by 10,000 to get it in Jansky, you're talking about 200 mega Jansky in L-band that we have received. So it was extremely bright radio event. The normal solar intensity is just very down here. You can't see it. So that just happened that we saw it on our interferometer. The two curves are just two of the antennas, the intensity that we recorded on two of the antennas. The next day, May 9th, we had again a fairly violent event, again in the morning. Not quite as bright as the previous one, but it is still reaching 10,000 SFU, so extremely bright. But this is really not the purpose of our setup. The main intention there is to have a demonstrator for interferometry. And this, of course, is the main effort. Now, what we have is 3 antennas, and the challenge was that we wanted to use 2 ADA and Pluto SDRs to get all 3 baselines. Obviously, the Pluto that we are using is a modified version, so it has 2 input channels. So we can put 2 input channels on one Pluto and 2 input channels on the second Pluto. The trouble is that they are not synchronized. So if you want to correlate the west and the east antenna, you have to do something about it. First thing is that you clock them from the same clock source, but that's not sufficient because the 2 Plutos, they have a time delay. You start them up and they have a time delay, and that can vary from time to time. So what you do is essentially, in order to align them time, is to look at a correlation of the same signal. So you correlate, or you try to find the best correlation between Pluto 1 and Pluto 2 on the same signal. And that's what we do. We form the correlation function and look for the maximum of the correlation functions, and that defines our time delay between the 2 Plutos. And actually, we were testing that in the lab and dealing with the software to do that. And today, we had the first try to have that on the real interferometer setup. And this is what we got. So we now can correlate 3 baselines since they have different baseline spacing. The corresponding frequency of the fringes varies. This is a cross-correlation function of the 3 baselines. And we have a transit at noon, which is around here. And theoretically, all 3 signals should reach a maximum there. So I'm blowing that up a bit and showing just that maximum. So they're not quite perfectly aligned, but almost. And we do have an offset to the nominal sun transit. So the nominal transit is at 11:29 UTC, which is around here. And that's a delay of about 7 to 8 minutes. And that corresponds to a angular error of 2 degrees. And that's quite explainable because we do not know whether exactly we are in the east-west direction. So what we think is that we have a slight offset of 2 degrees in our east-west direction. But we are going to monitor that for the next couple of days to see whether we always have this good alignment at around noontime or at the time of the sun transit. So that's just some first results that we get from today. What we can also do is we can, rather than do a cross correlation, we can do an adding interferometer by just taking the vector add of the 3 signals. And this is what we get from an adding interferometer. So all this is work in progress. We're happy working along that. And as I said, essentially the basic idea behind that is to have that as a demonstrator and as a experiment for graduate students. That's the whole purpose of the thing. Okay, that's all I wanted to show. Any questions?
All right. Well, let's get
On
Vanessa
on this last graph, I see 3 colors.
Yep.
Why 3?
Well, because we have 3 baselines.
Oh, I see. Okay. And
These are the
there are
three
different
different-
spacing, and so you have different harmonics here going on. Okay.
Well, it's not actually an harmonic. It is determined by the distance between the antennas. The same as here, we also have 3 different fringe spacings, which are determined by the antenna distance. So the smallest distance gives you the lowest frequency. So the green curve is the correlation between our, in this case, the west and the middle antenna, which are only some 2 meter, 2 meter 30 apart, and the other one are 7 meters something. So that's where you get the different fringe spacing. And the whole idea is that when you add more and more fringe spacing, you get a more clear definition on where exactly the maximum is.
Thank you.
Okay. Yeah, I had another little question. So if you, when I was looking at the strip charts that you showed of the solar flare, I was wondering, like, if this was recorded with the interferometer setup, why are we not seeing the fringes?
Because we are showing total power here. That's not the correlation.
Okay. Yeah, I just missed that somehow. Okay, thank you. Then that's clear.
I forgot to mention that this is just from single antennas. I don't have it with me right now to show the fringes. What happens there is that all of a sudden the fringes get much bigger than the previous ones because of just higher intensity. The fringe pattern stays in place because the sun doesn't change position, but the fringes just gets more and more intense.
Okay, thank
All right.
you. That's clear.
Anybody else for Wolfgang? Vanessa, how are you doing overall on the project? This is great results for your project, but what else are you doing?
Yeah, thank you. That's really great results. I'm also like trying to work on the data reduction steps. So now that we got the correlation, how to get the visibility and then the phase of the different baselines, and then try to match the different baselines with the phase and visibility, how that behaves, and then testing with the different bandwidth, and also if you observe at different frequencies, how that behaves, and maybe if there is still phase difference if you observe at different frequencies. So there's still a lot to test and to learn from that.
Excellent. And you two, Wolfgang and Vanessa, if you want to put some of these interim results or the flare data in the journal, I'm all for it, under observations or even with a paper. But that'll give you some quick results in publishing.
Yeah,
So,
we could maybe write a short article about the solar flares. That's certainly something that could be done.
That'd be
Yes,
great.
for sure.
All right. Well, thank you, Vanessa. All right, let's see. Edward.
Yeah, so at the moment I have no big things to share. I'm just working on some like random little projects here and there. So yeah, I was last week we finally had some days of reasonably stable weather. So I switched back to 1420 megahertz for a short while, doing some observations with a 3-meter dish. I tried to do observations of M31 Andromeda Galaxy, but unfortunately I wasn't successful. I don't know exactly why, but I think the dish has a little bit degraded and deformed over time, so it's not as good anymore. And I also did a observation of the H complex, so this is high velocity cloud, which I could fairly easily detect a couple of years ago. And yeah, it's fairly clear that it's not as good anymore, because I could still detect the H complex, but it's much more noisy. So some other things that I've been working on, I have been playing around with some alternatives for IF average, looking into that. So I tried to get Marcus program to work under Windows, but ran into some problems there. So that's kind of tricky, but in the meantime, I did learn something about GNU Radio, started playing around with that. So yeah, I'm having quite a bit of fun with that. Yeah, that's about it for now, actually.
Okay, any questions?
I've got a question there for everyone, which is if these dishes degrade, in what way do they degrade? And is there something that can be done about it to get them up and running again?
Yeah, so what I mean is that, so this is actually a bit of a strange story, because this is not a normal like 3-meter dish that is just sitting in my backyard all day. It's actually a dish that is built out of like 8 segments that you can like assemble together to form the dish. And so it's most of the time it's just stored in a shed where it's safe from the weather. And then if I have a couple of weeks of good weather, I just like assemble it and do some observations and then store it back in the shed when I'm done. But the problem is that like every time you assemble it and disassemble it, of course, it's gonna cause some like deformation, especially of the mesh. So I used it like aluminum fine mesh as for the reflector, and yeah, it starts like deforming over time a little bit. So I think it's just a little bit out of shape. That I think that's the issue.
Is that something that you can correct, do you think?
Well, that's quite tricky. I've tried some things. So I've tried to like measure the position of the segments with respect to the focal point and try to correct that, but that didn't help much. So I think it's if I really wanted to fix it, I would have to replace the mesh, which is quite a lot of work actually. So I'm not really want to do that this year.
Sorry, the other day I was asking the question because the other day I was thinking about this, and I don't know much about when it comes to radio stuff, but if you look at visual astronomy, people talk about things like quarter wave or 8th wave or 10th wave. Well, I mean, if the wavelength of hydrogen is 21 centimeters, then a quarter wave of that would be 5 to 6 centimeters, which maybe Alex could tell me. 'Cause I'm obviously missing something here, but I'd have thought you'd have had 5 or 6 centimeters to play around with in terms of deformation before we meaningfully affect the. No, I can see Alex
No.
is nothing. I'm
No.
wrong. I'm completely
Um,
wrong.
Before we get off topic, I was going to suggest something to you, Edward, just as a sanity check. Get some of these 12-inch square lucite or acrylic mirrors and cut them up into maybe like 4-inch squares and arrange them in patterns and point it at, put the dish at the sun, and just get some kind of a sanity check on the focal point.
Yeah, that's actually a pretty good idea. I thought of that as well, but I think it's a little bit hard to glue it to the actual mesh. So what I did for now is that I have like a little setup that I can actually like tie a little rope from the focal point and hold it at the very edge of the dish to check if at least like the vertical position of these segments is right. If you understand what I mean.
Okay.
Maybe
All
a
right,
comment to what Andrew just said. The rule of thumb is 1/10 of the wavelengths should be the accuracy. So it's not a quarter. You need 1/10 in the radio regime, not to lose major part of the efficiency.
Yeah, and I remember looking at the there's a plot that shows efficiency versus RMS surface area, and even when you get down to a tenth, you're already at like 60% efficiency. So yeah, it drops off quickly after that.
Yeah, okay. So that would be a fairly decent explanation then, because like if the surface was like good to within like a centimeter or half a centimeter initially, and now it's like a little bit bent everywhere, and it's like good within like 2, 3, or maybe 4 centimeters, then that would already like degrade the performance quite a bit. Okay, yeah. Then I think we know what the culprit is here.
all right. Okay, well, keep us informed on how you plan on fixing all that. That'd be fun to do. Okay, thanks. Andrew, why I've got you since you were talking, what do you got going on?
Oh, right. Well, I mean, sadly, my mum died 3 weeks ago, so that's been dominating my life and the funeral, and also illness beforehand. So it's limited what I can do. However, I have, after my initial success with mapping the Milky Way at hydrogen with my Farmigan explanatory array, I'm now doing a more protracted process of collecting more data at each point. Now for a week at a time, a drift scan at the same elevation to try and improve signal to noise ratio to see if I can get a clearer signal on the sort of the arms behind the arms, if you understand what I mean. And also I've changed the way that I do the elevation so that I can get more data points as well. So that's a process that I've started, and that's going to take about 6 months from beginning to end to finish that. And the other thing is that I'll just show you. So I share my screen. Remember how to do that more. So share. Where do we do share again? Oh, share. Here we are. Share. So we were talking about that flare, or those flares, and the aurora. Sorry. So these are pictures taken from my back garden, just using a handheld phone. So just amazing. I'm in the middle of a suburban area, so it really was quite impressive. And the reason I've shown that is because I had to look at this is a SID monitor from, this is not quite the same day, this is the 7th, but we've got the 7th and the 9th, and you can see that the sudden ionospheric disturbances are staring bonkers on the SID monitors, with all sorts of flares, one after the other, coming through over the last week or two. So I thought I'd just share that. Thank you.
Spectacular.
All right, any questions? All right. Well, we're really sorry about your mom, and I hope you guys and the family are doing okay. So
Yeah, thank you.
just all right. Let's see, Dimitri.
Hi to all. I'm glad to see you all. I just prepared a short message about solar activity and solar radiations. It is not about recent flare, but about slow varying solar activity. Just a moment. Do you see it?
Yes,
Oh, okay.
looks good.
Yes. This is work. This is a very long work, more than no more than 1 year and more, uh, mm, about traces of solar activity for high frequencies and in millimeter wave band. The questions, the problem questions is for millimeter wave band that uh, activity is very well seen in low frequencies in centimeters and after 20-30 gigahertz. This is millimeter wave band. Usually, some events of activity are not expected. Any radiations, any additional radiations connected with activity usually dies out higher than 20-30 gigahertz. But some residual radiations can be expected. Usually activity, usually solar activity is measured, the flux is measured in centimeter waves, 2.8 gigahertz, Learmonth Observatory 2.7 gigahertz, and parameterized by solar flux index. Oh, okay. As you see on the plot, activity components, slow varying activity components is seen for low frequencies, lower than 20 gigahertz, and after and higher than 20-30 gigahertz. The activity as expected is dying out, and only some residual remnants of activity could be seen for frequencies after 20-30 gigahertz. Now is we are as expected. We are now in about maximum of 25th solar cycle of activity, and I have measured solar temperature in 24 gigahertz band. This January, February of this year, mm, versus of solar flux index at centimeter wave 2.8 gigahertz as parameter of activity. Data for solar flux index is taken from American Space Weather Prediction Center, and I have seen some slight dependence on activity and 24 gigahertz. This is a metered band, and this solar data is needed by amateur radio operators who they they needed this data when for receiver tests when the sun is used as a beacon of radiations, as a beacon of as a well-seen beacon in the sky, and receivers could be tested. This is my old transfer for amateur radio for terrestrial links to 0.6 meters dish is used for this transfer, and it's used as radiometer, a solar radiometer. Some just two few words about journal where this result was published. This is journal for amateur radio operators who works in VHF and higher. Dubus. This is journal from in Germany, in bilingual, in English and German. This journal usually organize popular contests for EME operators. Several popular contests during the year. And accept papers about radio astronomy, mainly moon and sun radio astronomy, but I think it's open for other subjects and sky observations in radio. And many moon bouncers use their dishes for sky observations, like pulsars, galactics, and I just know about it. Also I measured 38 gigahertz radiations from sun. This is day data 10 years ago in 24th cycle of solar activity in 2014 years. The dependence of millimeter 38 gigahertz activity the dependence on activity, on solar activity, is still seen, and maybe more steep than M24 gigahertz. This is 38 gigahertz radiometer, 2.9 meter dish, and converter in dishes was bought in eBay. Now immediately for converts down converter for 38 gigahertz and used by me for solar measurements. This data this work also published in Bugos in 2016. Uh, if you need some preprints, I could share it. That's all for now. If any questions, I'm glad to answer.
Any questions for Dmitry? Did somebody just say something?
I would like to, oops, yeah, unmuted, I guess. But anyway, I'm interested. I'd done some attempts at solar temperature measurement at 12 gigahertz and came out with a temperature of the sun of between 8,000. Well, I came out with 10,000 Kelvin almost exactly for my result. And for all my uncertainties, I figure I'm somewhere between 8 and 12. And I wonder what you expect the sun's temperature to be at 12 gigahertz there, Dmitry. Go ahead.
And 12, maybe 12 gigahertz, maybe even as you can see, this about 10, 10,000, 12,000 Kelvin and 24 gigahertz. And for 12 gigahertz, I could expect even higher, maybe 15,000. But the dependence of solar temperature and 12 gigahertz is more sensitive to activity, and the temperature could be varied more in more higher range than for 24 gigahertz, and may be from saying from 10,000 Kelvin to 15,000 Kelvin. As I don't know exact what temperature for 12 gigahertz, but I think so.
Thank you.
All right, any other questions? Love your updates there, Dmitry. Keep going. We like to have them. All right.
Thanks.
All right. Thank you. Robert Lucas, who probably has the worst time zone thing. And Robert, did you guys see any southern auroras? That's what I'd be interested in.
Well, the weather here hasn't been all that good, and it was rain, 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 rain. So I didn't get to see them from here, but I've seen them from Svalbard and Tromsø and Yellowknife in Canada. I've seen them. So what I thought I would do for this time is if I'll try and share my screen. That doesn't look good. So basically, these are when we went to Dallas for the conference, and we also saw the total eclipse. What I thought I would show is that even though there was a lot of clouds, that
hi, Robert. Can you go ahead and go full screen?
So how do we basically do that?
I
don't think that's what we want.
I think it'd be the bottom kind of. Is that PowerPoint? Wow.
I don't see anything that says full screen. See, I don't. You can still see the pictures. I can still. I can.
Yeah,
still
go ahead. Go ahead.
So anyway, so this is a picture that my grandson, 10 years old, he was at the conference with us, and he took this picture. And here's the next picture he took. Then he did this one, and he did this one, and this is one I did. Okay, and and here's a flash spectrum, and as you can see, it went from all of the Fraunhofer series to like this one here is like iron 14. No, that's red, so that's iron 10. Here's iron 14, and here's like the H alpha. I haven't gone through and calibrated them, but anyway, I thought I'd show that it wasn't a total cloud shut out for the eclipse. It actually works for everybody. Okay, so that's basically it for me. So now, how do we undo this screen sharing routine?
Usually at the top of the screen, you click the unshare.
There we go. So we're back. So anyway, so it was okay. So it actually worked for me.
All right. All right. Any questions for Robert? Okay. Alex.
Good afternoon. I really don't have much to share. I might show you one slide of this ongoing project to stabilize my my remote SDR. Let me see if I get the two things going here. Share screen. Now if I can move it over. Let's see. Anyhow, I've been going on a couple months now trying to cool this AirSpy SDR in a remote box. And this is the latest development where this is heat sinked. I have some tech coolers, and this box isn't fully populated yet. A couple more relays are required, but I'm using dual controllers now to cool it down to 85 or warm it up to 75 Fahrenheit. This is the control system now. That this one uses bidirectional techs. What I think, I want to see how well this works. And then I found some 5-watt SMT resistors that are big enough to actually solder by hand. And rather than doing this reverse cycling of the tech coolers to just use resistive heating for the cooling, or the heating, excuse me. And as I said the last time, I was surprised, but the main thermal conduction or dissipation path to the AirSpy is through the SMA connector. This is where the heat comes out here. So I made this 1/8-inch copper heat sink that captures this. In fact, these nuts of the SMA attach it here, and there's some thermal adhesive that ties these together. So it's sort of, I haven't tested this yet, but this is the path. And this is going to be in like a little foam box to insulate it from the rest of the structure. Any questions? That's the story.
All right, thank you. Let's see. Jason.
Yeah, so I've done some rebuilds on my dish. I rebuilt the center section to make it more robust, and I also ended up extending the size by 10 inches along the surface. And I noticed I was, if any of you who are on the Facebook group, I posted some SunScan results a bit ago, and I had significant side lobes showing up. And several people said it looks like surface area, and specifically somebody said it looks like your dish is too flat. And I this weekend, after a couple of interruptions from other things in life. We had a lot of rain this week, so I didn't have a chance to get it out and work on it. And then I was dealing with a kidney stone of all things this week, which really sucked. but doing better now. But I did discover yesterday, when I finally got a chance to get it out, and the weather's been nice. I did some vertical measurements on the original rib sections at the very end, and I found that it was significantly too flat. Somehow when I rebuilt it, I messed up my ring position on the umbrella part, and so I had it like almost 25 centimeters too low at the extremes. And so I corrected that yesterday, did some measurements all the way around, got some variations around the perimeter corrected. And actually, I'm still scanning as we speak. I'm going to do let's see, I'm going to do a share screen here. Screen. Yep, here we go. Okay, so let me put this up here. Oh, there we go. Okay, so this was the results before I corrected it, and you can see the side lobes are just horrendous. And so what I ended up doing was correcting. Like I said, the dish is much more. I've corrected the shape issue, and this is the result that I've gotten today. And you can see a significant difference here. So the side lobes are almost completely gone now. So and this is
Jason,
actually,
for the rest of us, can you actually point to where you would say the side lobes were? I'm not following quite where you're considering
so
side
here's
lobes.
so can you see my cursor?
Yes.
So here's the main transit peak. This is a total power transit scan of the sun. Here's the main peak. The beam width is correct. If I measure half power or 3 dB points on this main section, it's correct. But these side lobes are just, and this one actually comes above the 3 dB point, which is just horrible. And so anyway.
And so the x-axis is time.
The x-axis is time, yes. And the units are in minutes. So the side lobe peaks are roughly 30 minutes separated from the main peak. Yeah, so this is what my current scan, and it's still underway. I'm still scanning as we speak.
And so time would be on the 3 strip charts on the right, not the one on the left. Okay, that makes more sense.
Yep.
And so we see 1 bump instead of 3 like we saw before.
Yeah.
That's
so I found the culprit, and it was easy to correct. So my suspicion is that I introduced a good bit of error when I rebuilt it, but I believe based on my measurements yesterday, I believe that even my original dish that I did my M31 and M33 scans with still had some issues. I believe it was flatter than I had intended, and so I probably had less than that. That probably explains some of my less than stellar performance on it. And the great thing is, even with the misalignment, I still got decent results with it. As you can see, even the one when it was significantly out of focus, I still got the main lobe is actually still fairly strong. And the way I was doing my transit scans, the nulls were the places where I was doing my my reference, my 2 reference scan, the pre and post reference scans. And so it just so happened that even with my poor design, it still accidentally worked. So, but I suspect now that I've corrected that problem, when I repeat those transit scans of M33, and I'm actually doing M101 again tonight, I suspect that my results will be a lot better. So, so that's kind of where I'm going with it. It's just it's a good practical lesson in sometimes you have to go back and actually measure the thing to make sure that you didn't build it wrong. Because I had done the math, laid out the profiles on the ribs, and they were all correct. But if they're not positioned correctly, then the shape is way off. And so that's what I had. My umbrella was open too far is basically what the deal was.
How did you measure how did you measure that at the end point where you determined it was too flat, and then you determined
So
you fixed
yeah,
it?
so what I did is I set it on my driveway, which is a flat concrete surface that's level, and there was enough, flat hard surface to reach out to the edges, and then I basically cut a piece of PVC pipe to the expected y coordinate, if for that point, and then I basically just set it on the ground and put it next to the rib to see how close is the top of the rib at that point. And I just basically adjusted my ring until they were all close, and then I had to go back and correct minor variations around the perimeter because it wasn't perfectly aligned. And so now it's all flat and the proper shape, and as you can see, the profile is dramatically improved. So I also found on a side note, I found that when I was doing a transit scan of the sun, that I saturated my receiver and the peak was flat, and so I ended up having to reduce my gain as opposed to when I'm doing hydrogen line searches. And I hadn't seen that before. I guess I just got lucky before in that the overall level was low enough that it never saturated. But I had to reduce it by about it's normally at about 49 dB of gain, and I reduced it to like 25, and that gave me a lot more headroom. So
Okay.
yeah, that's all I've got going on. I'm excited to see how the performance is going to bear out with my extragalactic source transit scans. So,
All right, one last technical question just for the crowd. What is the formula you use to calculate the expected height on your rim?
so let me. I gotta go look it up. I basically. Let's see. Here we go. I'm still sharing my screen, right? No, I'm not.
No.
Okay. I'm gonna pull up my. Actually, I'm gonna share my screen once more just to because it's probably easier to show rather than tell here. So what I did is I built a design tool in Excel, and I'm opening it here. Give me just a second for it to open. I mean, it's literally it's literally high school level quadratic functions. So what I have is I have my x coordinate in inches, and then my y coordinate is a quadratic function with the diameter input and the focal ratio as an input, and then that allows me to, and those inputs are in meters. So then I convert to inches so that it's in the same units as the X coordinate. Because when I actually did my construction, I used a yardstick to measure it off, and I basically just drew on the plywood with drew my X coordinates on the plywood with a pencil, laid it out, and then marked the Y coordinates, and that's how I built my structural members. So yeah, so that's how I did it. I guess, does that answer your question?
Yeah, there's a formula that there's a formula for the X distance, and then the height above the X distance for
Yeah,
the
it's basically just it's just the equation for a parabola that's centered on the origin. So it's basically y equals some constant times y squared, right?
okay.
And then I just built the calculator to calculate that scaling constant based on my F to D ratio and my diameter that I wanted. And that way it would automatically rescale it to allow me to just mark off measurements then.
Okay. All right, great. That's be useful for a lot of people.
Yeah, and I am planning on documenting the details of my dish design and making that available to the community, because I think it is now that I've worked kind of all the problems out of it. My whole purpose of this project was, well, I wanted to do it myself, but my guiding principle is I want to do something with materials that I can buy at Menards or the hardware store, and not any specialized equipment. So I have no tracking. I mean, it's built out of plywood and zip ties, So, and that was the purpose, was to make it very low tech, and to see how much performance I could squeeze out of something that was very low tech. So,
okay, great. Any other questions? All right. Thank you. David Westman has some updates on the next Western Conference.
Well, not exactly. I do want to say that we did have a successful Western Conference, thanks especially to Bob Strickland, who was my proxy on the ground, getting together all the details, including helping line up the guest speaker and other things. And it was really a good conference, but it convinced me of one thing. Since I can't travel anymore from Hawaii due to a lot of complications, I think I'm basically going to call it quits for organizing Western conferences as of now. And also, I'm not going to run for another term as a director of the society. So the position as coordinator of Western conferences is open. And if there is no person to fill that, the Western conferences will not be held any longer. But if there is a person to take on the job, which I stress is really quite taxing at sometimes, especially putting together the proceedings, I suggest that the next conference could be held in Socorro, New Mexico at the VLA, because they owe us one since they canceled 2020. And they might well consider a conversation about a new conference there to be in order, I hope. So in any case, as of now, the question of a Western conference in the future is open to anybody who wants to try to organize it. And I hope that will be happening. And I will help if necessary, but I'm not on the hook for this any longer. Thank you very much.
Well, on behalf of the board, the members, myself, the officers, we really appreciate the multiple years that you've done this Western Conference. You've really enhanced SARA's capabilities, etc., outstanding venues you've done. We really appreciate it, and thank you very much. And people have a big shoes to step in when you pick this thing up, but it's doable. So if you want to volunteer for the Western Conference coordinator, give me a call. You can call David too, and I'm sure David will be around online to help you out for advice. And obviously, Bob Preston did a great bit of stuff, so he's very knowledgeable on setting it up too.
Bob
So
Strickland. Bob Strickland.
I'm sorry, Bob Strickland, and sorry, Bob. And so you won't be alone when you set this thing up, and we can really use someone just to coordinate it. All right, thank you, David, very much. Any questions for David?
I just want to say thank you, David. Thank you so much.
Yeah, thanks from my side as well. You organized some very excellent conferences.
All right. Okay, thanks, David. Helen.
Yes, I've been speaking with Tim and he's helping me. I have all the information now to download the galactic hydrogen data onto my scope so that I can be up and running.
Nice. What are you going to use to process it software-wise?
I don't know yet. My husband's going to be helping me and we're going to be figuring all this out. It's all put together, but there's still plenty to do.
All right, you're in the fun part of this thing.
Oh, okay. Well, at least I have help and I appreciate it. Thank you.
Okay, thanks.
Uh-huh.
Bob Alexa.
Yeah, hello. Nothing to report. I just enjoy listening. I do have one question as a new person from this year. When it comes time to redo the dues, do we just do them 1 year at a time, or when you go to the website and click on renewal, can you add like 2 or 3 of them to the cart so you can renew like 3 times at a time?
Oh, you're really pushing our store software if you do that. I think it gives you a life membership or it gives you a yearly one. So I think just do the yearly one, and because otherwise I think that's all it's capable of doing right now. We've got a very rudimentary store software at the moment.
Okay, I just didn't know if everybody always renewed 1 year at a time or if you do it for 2 or 3 years at a time.
Yeah, I think right now it's 1 year at a time, but that'd be good idea if we can enhance the software. That'd be great.
Okay, thank you.
Okay, thank you. Don Latham.
Actually, I've got really nothing at this time. Still beating on it. Trying to get the dish to move.
Okay, thanks. Bruce.
Yes, let's see. I'm going to flip this over to there. Am I unmuted? Everybody hearing me?
We are.
Okay. I'm going to try a share screen in a minute, but first I wanted to comment on out of Dallas. Thanks a lot for the guys that put the conference together out there. It was a very good conference. And I set up my IBT out in the courtyard in the area where the university had told us to set up experiments. And it was basically an area where there were a lot of students around. So I had an IBT set up watching the eclipse and recording the whole thing, and same time being forced to put on a teacher hat and explain to students black body radiation and other such things. So it was really quite interesting. It was really quite fun working with the students once I kind of got into the role of that. So anyway, I will have something on that for the SARA journal pretty soon on that. I'm working on it. I'm not sure when the next journal is coming out, but anyway, in another week or two, I should have the paper together on that. And then
June 12th.
What's that?
By June 12th.
June 12th. Okay, I need to make sure it's together by then. Okay.
Now, Bruce, the IBT is the itty bitty telescope that runs at,
itty bitty,
which
12
is a small
gigahertz.
dish at 12 gigahertz. Yes, thank you.
That's right. Now, in my case, I've got my own version of a processor, not using a satellite finder, and that gives me a lot more, resolution and linearity and power measurements and things. But anyway, while I was out in Dallas there and playing with that and watching the eclipse and very much enjoying that and the interaction with students, I had my 408 megahertz system running at home and had a rather wide beam width antenna on it. And watching the eclipse where I had roughly the sun was 80% covered at my home in South Carolina. So I got the recording on that. So that's another paper in the works. So if I get myself together enough, I may have 2 papers in there by June 12th for that on the same eclipse there. 408 was a lot noisier of a thing because I had some reflections off of power lines and other things. A wide beam width antenna is an invitation for reflection problems. Other thing, there was some mention about the solar events that have been happening. As a matter of fact, specifically May 8th. And I'm going to attempt to share screen. I usually manage to screw this up, so we'll see. Okay, does everybody see a spectrogram in the background?
Yes.
Okay, so that was one of the things that was fairly typical there. You can see on the side there, there's the frequency reading of the receiver, and then there's universal time across the bottom, and the color is related to intensity. Closer to red is a much hotter. So we had a very hot flare there and had there were actually many rapid bursts around there. That whole day was full of that. That was just one of the better ones. So I thought it was rather interesting. Unfortunately, at this point, don't have a calibrated system on that because I'm using a active dipole, which is a shortened dipole with a optimized preamp right at the antenna. So the dipole is only 1.8 meters long, so it's on the short side. But anyway, so getting an accurate calibration on it is still a problem. So I can't give you something and say this is the temperature of that. But it was definitely hot, and that's what I got from that. So anyway, and over the few days before and after that, there was a lot of stuff. And almost every day for the last couple of weeks, there's been a few solar bursts, none quite as hot as that one, but definitely a lot of them there. And at this point, I'm going to attempt to unshare screen if I can find the button. That's new share. Where is the unshare button here? Can somebody tell me? It says you are screen sharing. Stop share. Did that stop? Yeah, that looks like that stopped the share. I successfully got in and out of a share without Rich having to kick me off and let me back in. So that's a new one for me. Anyway, that's about what I've been up to. And like I said, should have a couple of papers for the journal here shortly. And that's about it from here. Any questions?
Now, I do have one for the general crowd here. Was this actually at the level of a Carrington event? Which sounded like it should have been worse than it was, taking out power grids and things like that. Anybody heard anything about that?
From what I heard, we were not anywhere near quite that same level. The Carrington event had the thing that it was aimed directly at the Earth when it, hit. Besides being an exceptionally strong one, so you had that combination. And the coronal mass stuff misses the Earth or goes beside it, you don't get anywhere near as much activity or potential damage from it. So I don't think it was anywhere near what the Carrington event was.
There was an X8 flare that just happened on the 14th. I was going to show a graph of some data on that, but it wasn't directed at the Earth, as you say, and that's a big factor, is exactly what the direction is.
Bruce, beautiful graph, all colors. What was the receiver?
Okay, I was using an AirSpy Mini, and using C sharp, or not, yeah, SDR sharp, excuse me, to feed into the Jim Sky spectrograph arrangement there. And that works pretty good. So that's got a little bit wider of a range than the little RTL SDR things. And still, in order to get that frequency range, good performance, I actually used a down converter or an up converter. I converted it up to 120 megahertz, and then the SDR Sharp has the ability to correct for a down converter. So I did have a down converter to bring the frequency up to where the little SDR works the best. But anyway, it was a AirSpy Mini, and which has got a little more resolution and a little wider frequency band than the little RTL SDR things. Other than that, it's talking to it's quite similar.
It looks so much like the Radio Jove presentation as well. And I just wondered if either one would be similar or one would be better.
Okay, Radio Jove is using the Jim Sky spectrograph that I used. The only thing is they're using a different SDR on it, and that's about their SDR has a slightly wider frequency range. I think it's an SDR play or something, but it's a very similar arrangement from that point of view. And the final spectrograph looks exactly the same type of layout because, well, it's the same program making them. Go ahead.
Thanks very much.
All right, thank you. And Bob, why don't you go ahead and show your picture you wanted? Did I lose Bob Strickland? There you go.
No, I'm here. Can you hear me okay? I think you can.
Yes.
This is from my monitoring system. I made a presentation yesterday at the North Texas Microwave, and this is my slide from that. But I'm listening at WWV at 10 megahertz as part of the Personal Space Weather Station group. And this is from a few days earlier. This is from the 10th, but it just gives you an illustration of what the 10 megahertz signal does at my location. Basically, it's shifting around due to Doppler shift caused by ionospheric changes or conditions changing. And but there's always some signal flowing through that. And then when we have this X8 flare that happened right around 1600 UTC, so this is time in hours, you see the signal is just about totally wiped out during that time frame. And this is the signal strength and magnitude down here where it just sort of squelched everything down at that frequency and below was squelched, and reported hearing about AM radio stations and things having problems. So it was a pretty big deal. And I'll try to find a link that I had of a picture that was taken by NASA of the sun. You can see a really bright spot on the bottom, from the picture's point of view, from the bottom right side of the sun. So it was an interesting event. I have another set of pictures that are similar to that. I have two antennas. One is orthogonal to the other at 90 degrees. And that one was still copying a little bit of data during that time frame. So there was some change in the wave shape too, I guess, through the ionosphere at that point. That's really all I have today.
All right. Well, thanks, Bob. Monroe.
Sorry. Yeah, I've just got one item. I posted shortly before the start of this session onto the Google group information about a presentation I did a week or so ago on the NASA General Coordinates Network for those people looking for what's the latest, hey, looky what I saw by the professional astronomy community in a variety of wavelengths and types of observatories. You can look for things like, hey, some observatory that I've never known before just spotted a GRB, and you can get the raw data, the coordinates, things like that. so you can do the early correlation and verification. And if you've ever wondered how observatories talk to one another about new findings, the NASA GCN is how they did it. And so I put that up on the Google group for people to take a look at. There's a video that I produced. It's about 23 minutes long. It's on YouTube. I provided a link to that as well. That's it.
Great, thanks. Dennis.
I don't want to waste your time. I'm an extreme newbie. I've had a ham license since I was a kid. I've been an amateur astronomer, mostly visual, for about 40 years, and I love the concept of melding the two. I really am enjoying listening to you people. Thank you very much.
Well, thanks. A bunch of us are ham convertees too, so welcome. Preston.
Well, the only thing new is I got a vector network analyzer for my birthday, so I haven't had a chance to use it yet, but looking forward to it.
Okay, thanks. Charles.
Okay, don't have too much going on. Yeah, we've had a lot of rain. We've had 8 inches of rain or a little more than the past few weeks. So been keeping the dish down lower elevations since mine can catch water, solid surface. So I've been down at minus 24 to minus 32 degree declination observing. I do have a good, there's a good spot that I usually do calibrations at if you're able to get down to low angles, is minus 32 degrees declination and 3.92 right ascension. That gives me usually a very good flat line, low hydrogen contamination, so I can go for days. Once I've calibrated that, it usually,
what was the right ascension of that again?
3 weeks once I calibrate there.
What was the right ascension?
3.92. Yeah, 3.92. So just before you get to the 4th hour angle. There's kind of a dead zone right in there, and that seems to be big enough that that my dish gets a. I think it shows up on the radio eyes as being 14 Kelvin or something. So works pretty good. Anyway, that's about all I've got going.
Let me show you another view of that. Just 1 second. Here. So we're down down in this region. So this is Marcus Leach's map, SARA. There you go.
Okay. Well, thanks. Let's see. Tom.
Good afternoon. Nothing to report, just trying to keep my head above water. But, or at least that's how it feels.
Well, we really appreciate you doing treasurer, and thanks for everything you've been doing. All right.
Yeah, I will. The one person asked about doing multiple year renewals. If you were to do that and you didn't do them all at once, I could probably make it happen so that you get several years at once if you were doing it, say, once a week. But you also need to drop a note saying that you really intend this for multiple years. I can probably make that happen, even though that's going to be extra work for me, because effectively those are, several renewals. And please don't do that as we come to the end of our physical year when everybody is renewing, because I can already see that that's going to be a great deal of work for me. The most time-consuming actions right now does seem to be the renewals. There's quite a lot of moving parts to that. But, and I don't know, like I say, so currently we only have ways to sell lifetime members, as they said, and annual memberships. So, but if I saw someone who was doing that, I probably would give them an extra year. And I think I've done that. One person actually sent 2 renewals, but he was renewing for the rest of this year and then the next year, because apparently he missed his renewal at June of last year. All memberships expire in June. I will say that just in case people have forgotten. Anyhow, with that, I'll let you go get back to it. Whoever's next.
You could just buy 20 years at once, and that becomes a life membership, and hope you live long enough to take full advantage of it, which is what I did.
Actually, there is a life membership which will charge you the $400, which is 20 times the annual membership. So that is actually a choice on the store, and at least one person has done that since I started being treasurer. So, but if you want to do 5 years or something like that, you'd have to do them 5 times, annual membership 5 times. You don't have to do 20 memberships 20 times to get your life membership.
Okay, thanks, Tom. Great work. Rick.
Unmute. Hello. Not much to report here. I'm working on a project with Dan for the Deep Space group. I'm trying to document on paper, on a PDF file, how exactly we collect and analyze data for radio astronomy at that location. And Dan gave me his checklist of how it's done, 1-page bullet points. But I'm up to 35 pages now of detailed documentation and pictures, so that the next person who wants to come along and use our dish will understand what software is required, how to install it, how to test it, and how to actually collect data and then analyze it when we're done. I'm finding that the checklist wasn't quite up to the task. So that's my big project for the week.
Okay, thanks, Rick. And Peter East, I think you're last.
Did I come in an hour late?
I think so.
Oh, sorry about that. I misjudged EST. That's my problem. Anyway, I've as you know, I'm messing around with pulsar data, and I wrote a paper in the last journal about tracking scintillation, trying to get the best SNR out of data. Since then, I've had another contact with another radio amateur. He's an EME amateur, but he's managed to detect over 20 pulsars with his EME dish. and he's been supplying me with data. So I've been using that data to drive my software and to prove it. So hopefully in the future, I'll be able to show you some of that data. But the interesting thing is that I can now compare directly with Presto. In fact, I'll probably get better quality data than Presto. But at least with this data that I've been given from this radio amateur, at least I can demonstrate that my software and Presto agree. So I've never really, I don't think Presto have ever, or the author has ever specified or described the algorithms that he uses. But I've published all of mine, as you know. And it's interesting to see that we can get very similar results. Okay, that's about all from me, I think.
All right, anybody got any questions for Peter? All right. Well, that's I missed anybody? And by the way, we are looking for we're going to put out the nominations. Bruce is going to get that to me. We'll have it in the journal and probably send it out to full membership. We're looking for half the board needs to renew. So if you're a current board member and you are up for a re-election, let us know that you want to do it again. And the officers, we need a couple officers on there. So we'll put out this nominations at least in the June journal. Probably send it out earlier, and then nominate somebody. If you nominate somebody, make sure that you ask them first that they want to be nominated. But then we're looking for nominations and for officers and board members for this next election for this year. Okay, they're 2-year terms.
I have a question, Rich.
Yeah.
Okay. With this membership thing, could we have a half-life membership based on our age statistics?
No, because if you do radio astronomy, you're so relaxed, you're going to last 20 years no matter when you start. I think that's the theory here.
I don't know.
Nice try.
Yeah, well, that's life.
Okay. All right. Thanks, everybody.
Thanks, Rich.
Friday is the Drake's Lounge Australia, and we're probably going to see a bunch of what happened to solar flares on the east, on the southern hemisphere. Okay. Thanks, everybody. Bye.
Thanks, Rich. Bye.